We're continuing with Chapter 2 problems, 2.3, Part 1, solve and check, and we're on number 3. 7 minus 9x equals 4. Alright, so we only have variables on the left side, so let's keep the variable on the left side and subtract 7 from both sides to isolate the variables on the left side of the equation, and make sure you realize that's not 9x, it's negative 9x. Negative 9x equals 4 minus 7 is negative 3. So now we need to isolate x by dividing both sides by the coefficient of negative 9. So let's divide both sides by negative 9, and we get x equals 1/3. So if we were going to write this using solution set, the formal way of writing the answer, that would be 1/3 if that checks. So let's go over and see if it checks. We have 7 minus 9 times, let's plug in 1/3 for x. On the right side we have a 4. And we're going to do order of operations on the left. Remember not to do 7 minus 9. Order of operations says do 9 times 1/3. So we have 7 minus 3, which is 4. So we have 4 on both sides, so it checks. Now another way to do this same problem is you could change the signs of everything before adding or subtracting a number to both sides. So let's do this problem using that method. So we take the same problem, which is 7 minus 9x equals 4. And if there's a minus sign in front of the variable and you prefer it to be positive, just multiply both sides by negative 1, which means you change the signs of all terms. That becomes negative 7, that becomes plus 9x, and that becomes negative 4. So you would get that by, what I'm really doing is multiplying both sides by negative 1, which is the same thing as taking the opposite of both sides. And now you would add 7 to both sides. So you have negative 4 plus 7 is 3. And then when you divide by 9, you're still going to get x equals 1/3. So just keep in mind that's an alternate way of doing it. Multiplying both sides by negative 1, it's the same thing as taking opposite of all terms on both sides, which is what I did. 7 minus 9x is 4 is the same as negative 7 plus 9x equals negative 4. In other words, you're going to get the same solution if you do that. Number 4. There are a couple ways to do this problem. First method is you've got the variable in one place, x over 4, and remember that's the same thing as 1/4 x. So I'd like to get rid of this minus 6. So I could add 6 to both sides. And that gives you x over 4 equals 7. Now what does this really mean? It really means x divided by 4 is 7. Some of you might be able to figure out x in your head, but another way of doing this is undoing that division by 4 by multiplying both sides by 4. So if I multiply both sides by 4, the 4's cancel over here, and I get x equals 28. And that should make sense to you. It's 28 divided by 4 that equals 7. So if I'm going to write that in a solution set, we would write that as 28. Let's go over here and make sure that when we plug that in, we get a true equation. So I need a little bit more space here. So we have to put in 28 for x over 4. So that means 28 divided by 4 minus 6. 28 divided by 4, remember division comes before subtraction, is 7 minus 6 or 1. And on the right side there's a 1, so it does check. Let's do this by getting rid of the least common denominator first. So I could take the same problem, x over 4 minus 6 equals 1, and multiply both sides of the equation by the least common denominator, which is 4, since there's only one fraction. So we're multiplying 4 to each term on both sides. So we have 4 times the x over 4 minus 4 times the 6 equals 4 times the 1. Remember, you have to do both sides of the equation by 4. And when you do this, the fractions will cancel out if you multiply by the least common denominator, so that I get x minus 24 equals 4. So you've eliminated fractions on step 1, and you'll still get the same answer, x equals 28. So that's an alternative method. Number 5. The left side of the equation is simplified, but the right side is not. So the first step here is to do the distributive property on the right-hand side and simplify as much as possible. So we have to do negative 2 times 2x is a negative 4x, and negative 2 times 5 will be a minus 10. It's still not simplified on the right-hand side. We have to combine the like terms. The 7 minus 10 is a negative 3. So you could write negative 4x minus 3 or negative 3 minus 4x. Now we need to get the variables on one side and constants on the other. So how about we add 4x to both sides so that both of the variables are on the left-hand side. And if the variables are on the left-hand side, then I want to subtract 4 from both sides. Now some of you do this in 2 steps. I like doing it in 1 step. So I have 0 here, and this will be a negative 3x plus 4x is just 1x. How convenient. And be careful over here with your positive and negative numbers. We've got negative 3 plus negative 4, that's negative 7. So that's looks like it's the answer if I didn't make any mistakes. And you would write negative 7 in braces to be more formal about it. Now let's check it. Alright, so to check, you write the exact same problem down. You underline it. Let me go down the page here a little. So we're going to check x equals 7 to see if the x equals negative 7. So we're going to plug in on the left side anywhere there's an x, a negative 7. And we'll simplify this side first. So we do multiplication. So remember, that's a minus 3 times a minus 7. That's going to be a plus 21, which is 25. And on the right-hand side, we're going to also plug in negative 7. And I'm going to do the order of operations here. Now remember, no distributive property when you check. What you do is simplify inside parentheses first if there's parentheses, which there are. And inside the parentheses, you've got to do order of operations, which means the multiplication comes before the addition. So we have negative 14 plus 5. And I still have to simplify within the parentheses. So I have negative 14 plus 5 is negative 9. Now I have to do this multiplication here before I do the 7 minus, you can't do 7 minus 2. Multiplication comes next. So you have 7 plus 18, because you have a negative 2 and a negative 9, and 7 plus 18 is 25. So this checks. So I got 25 on both sides, so negative 7 was the correct answer. Number 6. Got 10 minus 1/3 x equals 1/2 x. All right, we've got we have fractions here. So the easiest thing to do is multiply both sides of the equation by the least common denominator. Well, there's 2 fractions, a 3 and a 2 are the denominators, so 6 is the least common denominator. So I'm going to multiply 6 times each term on both sides. So I have 6 times 10 minus 6 times 1/3 x equals 6 times 1/2 x. So I've got 60 minus, now what happens here? The 3 goes into the 6 2 times, so that becomes 2x. And 6 times 1/2, the 2 goes into the 6 3 times, and I get 3x. All right, now it's an easier problem. I've eliminated the fractions. So I need to put the variables on one side of the equation. So let's add 2x to both sides. So I have 60 equals 5x, and then divide by 5. So I'm going to get 12 equals x, and I'm just going to write that as x equals 12. So using formal notation, That means 12 is the solution set. Now we need to check our answers, so we're going to plug in 12 for x and simplify. So we have 10 minus, well, 1/3 of 12 is 4, so 10 minus 4 is 6. And on the right-hand side, we have 1/2 of 12, which is also 6. So it checks. In fact, the check wasn't so bad here because of the canceling, right? The 3 goes into 12 4 times and 2 goes into 12 6 times. It became pretty simple. So this is the easiest way, I believe, to solve problems where you've got especially two fractions involved. Multiply both sides of the equation by the least common denominator, eliminate fractions, and then go from there.